You're listening to The Deep Dive, where AI voices break down big ideas. Every week, Nova and Echo guide you through the tools, trends, and thinking behind the AI revolution. No hype, no fluff, just smart conversations sparked by AI.
Does it feel like the world is changing faster than ever? You know, like new technology goes from zero to everywhere almost overnight?
Yeah, that feeling you have. Well, the material we've been digging into, it basically says it's not just a feeling, it confirms it. Change is accelerating, definitively.
Right. And the main engine behind this, according to everything we've looked at, is artificial intelligence. The speed, the sheer scale, the impact of its growth is just, well, unprecedented.
Exactly. We've got this huge stack of charts, data analysis covering pretty much everything. User numbers, infrastructure spending, performance trends, how companies are actually making money.
Competition, what it means for jobs, even the physical world, it's all in there.
So our goal today is really to unpack all of this with you, to pull out the most important bits, the key nuggets, and help make sense of what's really driving this transformation and, what it might mean.
Okay, let's dive in. Let's unpack this. And the very first thing that just leaps out from the material is the speed and the scale of AI adoption. It feels different because, well, it is different.
Absolutely. The data we have shows AI is being adopted at a rate we just haven't seen before. Think about ChatGPT. Now, the company, OpenAI, had been around for 9 years, right? But the material points to its public release, that explosion, feeling like the biggest overnight success in history. By April 2025, it hit, 800 million weekly users? Just staggering.
And the comparison the analysis makes is really striking. It contrasts the adoption speed of the internet with a leading US-based LLM, a large language model like ChatGPT.
Right.
And the data shows this LLM reached 90% of its current user base outside North America in just its third year, year 3.
Yeah. Now, compare that to the internet.
It took the internet until year 23 to hit that same global reach, 20 years longer.
So what that tells us pretty clearly is this tech didn't just slowly spread out from one place. It hit the world stage almost all at once, growing super fast across continents simultaneously. That instant global thing is new.
And that kind of explosive global scale, it demands equally massive investment, right?
Absolutely. The material really highlights the capital expenditure. The CapEx, the money companies spend on big assets like servers and buildings of the big 6 U.S. tech companies. Apple, NVIDIA, Microsoft, Alphabet, Amazon, AWS, Meta.
And their combined spending?
Hit $212 billion in 2024.
Wow. Just for context, how big a jump is that?
That's up 63% year over year. And the analysis suggests this isn't just like more spending as usual. It's a real shift. After previous tech phases focused on, say, storage and access, then distribution.
Right.
The big money now is laser focused on building the infrastructure for computation, for intelligence.
And it's not only the giants pouring cash in. The developer community, the people actually building stuff with this tech, they're rushing in too.
Yeah, the material used the NVIDIA ecosystem as a kind of proxy. The number of developers using their platform grew 6 times over 7 years, reached 6 million by 2025.
So that's another whole layer showing how fast and broad this adoption wave really is.
Exactly. So when you feel like things are changing fast, these numbers, they really back it up. This isn't abstract. This speed, this scale, it's already affecting the services you use every day, the economy, how companies work.
Okay, so we see the incredible speed, the huge investment, but what's actually powering this? What's the engine? The material goes deep into the tech itself, and it shows improvements are compounding, happening on multiple fronts at once.
This is where it gets particularly interesting. It's not just one single breakthrough. It's several crucial things getting better simultaneously, and they feed off each other.
Okay, so give us a sense of those compounding gains from the data.
Well, take the training compute used for the big AI models. That grew by 360% per year over 15 years.
Per year?
Per year. On top of that, just making the algorithms smarter, more efficient, that added another 200% annual growth in effective compute over 9 years.
Go ahead.
And then the hardware itself, the AI supercomputers, got better too. Packing more chips closer together, better performance per chip. That gave another 150% annual growth over 6 years.
Wow. So it's like the models are getting way bigger, the software is smarter at using the hardware, and the hardware is getting faster all at the same time.
Precisely. And it's not just one or two players. The number of powerful, large-scale AI models hitting the market is also exploding up 167% per year over the last 4 years. We're seeing major models from XAI, Anthropic, Meta, and others. It's a crowded field now.
And all this compounding improvement, it's leading to performance levels that are actually starting to beat human benchmarks in some areas.
That's right. The material pointed to the MMOU benchmark test. It covers a really wide range of subjects, like, high school to professional level stuff. In 2024, the average accuracy of the top AI models on that test went past the generally accepted human score of about 89.8%.
Past human level. And it's not just abstract tests, is it?
No, not at all.
Oh.
The analysis looked at Turing test conversations, too. Where you try to figure out if you're talking to a human or an AI.
Right.
Using a top model, GPT 4.5, back in March 2025, testers mistook its responses for human 73% of the time.
73%.
And there's this one specific detail in the material that really stuck with me. One AI participant, called Witness A, was identified as human with 87% certainty. And the reason given, it just had human vibes.
Human vibes from an AI. That really says something about the increasing realism, doesn't it?
It does.
And the sources, they also showed this visually. The evolution of image generation, like Midjourney, from version 1 back in 2022 to version 7 in 2025. The jump in realism is just incredible. By 2024, you often couldn't tell AI images from real photos.
And it's moving beyond just text and images. The material also touched on audio rapid improvement in translation, voice generation, mentioned tools like 11 Labs.
Okay, which leads us nicely into another key trend the material flagged, multimodal AI.
Exactly. AI isn't just about text anymore. Multimodal models, they're designed to understand and integrate text, images, audio, and video all together. More like how we humans experience the world, right?
Yeah.
And the material showed a huge surge in the release of these large-scale multimodal models, up something like 1150% over just 2 years. Language models also grew massively, up 420% in the same period.
So we're talking about models like GPT-4o, Claude 3, Chameleon, those were mentioned in the analysis.
Yeah, those are the kinds of models. The key takeaway here for you, the listener, is that AI is just becoming so much more capable. It can handle different kinds of information together, almost like we do.
So putting it all together, this compounding improvement, the move to multimodal, it means AI can tackle tasks that seemed impossible for machines just a short while ago. And it can interact with us in ways that feel much more natural, more human-like, across all sorts of information.
And building on these more capable models, the analysis points to something new emerging, AI agents.
Right. This isn't just your standard chatbot anymore, is it? The description was less assistant, more service provider.
Exactly. Think of agents as intelligent processes designed to actually do things, to complete tasks autonomously, not just respond to prompts.
And people are clearly interested. The data showed Google searches for AI agent just skyrocketed up over 1,000% in the 16 months leading up to May 2025.
Yeah, the interest is definitely surging, and the big companies are already rolling out these kinds of agentic features. The analysis mentioned OpenAI Operator, Salesforce Agentforce, Anthropic's Claude 3.5 has a computer use feature, Amazon Nova Act.
Okay, so these aren't just concepts. What can they actually do?
Well, the examples given were things like automating customer support cases from start to finish, actually resolving issues without a human needing to step in, or even controlling your computer screen to pull data from different places, maybe make a purchase, home automation, complex scheduling, tasks that require multiple steps in interacting with different systems.
So the implication for you, the listener, is potentially a huge shift in how you interact with tech. Instead of jumping between apps, you might just tell an AI agent what you need, and it figures out how to get it done.
That's the idea. But none of this speed, this capability, none of it happens without a massive foundation being built. The infrastructure, the economics, that's crucial.
And the material makes it crystal clear. AI CapEx, that investment we talked about, it's driving data center spending to levels we've never seen before.
Yeah, there was that really striking example of the XAI Colossus supercomputer, built in just 122 days. The analysis pointed out that's like half the time it takes to build a typical house in the U.S.
The incredible speed.
And then they doubled its size in another 92 days. And across the U.S., data center construction value grew at an accelerated rate, 49% annually over 2 years. Direct result of this AI demand.
But powering all these data centers, that creates huge challenges, right? The material had that stark quote, "There is no AI without energy."
Absolutely unequivocal. Data centers already used about 1.5% of global electricity in 2024. And that's growing at 12% per year globally.
And where is most of that consumption happening?
Highly concentrated. About 45% of it is in the USA. And this massive growth in demand, it brings up something called Jevons paradox.
Okay, explain that.
It's this old economic idea that when technology makes using a resource more efficient, consumption of that resource can actually go up, not down, because it becomes cheaper or easier to use more of it.
Like fuel-efficient cars leading people to drive more miles.
Exactly. The analysis applies this directly to AI. As AI gets more efficient, we might actually end up using more energy overall to power it because we find so many more uses for it. It's a real concern.
Okay, and what about the chips? The brains behind the operation?
Well, NVIDIA was obviously highlighted as a huge beneficiary. Their data center revenue made up like 25% of all global data center CapEx in 2024. Their own revenue saw massive growth, 78% year-over-year quarterly.
But it's not just NVIDIA, is it?
No. The material also pointed to the big cloud providers designing their own custom chips. Google's TPUs, Amazon's Trainium chips. They're building chips specifically designed for AI tasks. The goal is better price performance, especially for inference.
Inference, that's the cost of actually using the AI model day to day, right?
Right.
Not training it.
Exactly. And that cost dynamic is absolutely critical.
Yeah.
Training these massive frontier AI model is incredibly expensive. We're talking hundreds of millions, maybe even $1 billion per model. Training costs saw something like a 2,400x increase over 8 years.
And this is the key point from the analysis.
The cost of inference, the cost per token basically, the cost of generating each word or piece of data in a response, that cost is falling dramatically. The analysis compared the relative cost of, say, a 75-word ChatGPT response to things like electricity or computer memory.
Yeah.
And it's become incredibly cheap on that per unit basis.
Right, and this falling cost of using the models, that's what makes it possible to embed them everywhere. It connects to this idea of the material called text perpetual AHA.
Yeah, it's this pattern we keep seeing in tech. Declining costs for core technology combined with better performance consistently leads to this explosion in adoption and usage.
We saw it with PCs, with the internet.
Exactly. And the material showed this correlation. As the cost of IT hardware and services fell, measured by the Consumer Price Index, the CPI, the amount of compute used for AI model training, just soared. It's that same cycle repeating. As the tech to do AI gets cheaper and better, people find countless ways to use it, driving demand even higher.
So you get this powerful feedback loop. Tech gets faster, cheaper to run, that fuels adoption, which drives more investment, and around it goes. But in this crazy fast environment, who's actually making money? Who's capturing the value?
That's a big question the sources raise. The economics are still really dominated by that huge initial investment, the capital intensity, the massive infrastructure. So the material explicitly flagged questions about future monetization plus profits. It's still unfolding.
And competition is just incredibly fierce. It's not just the usual suspects. The material highlighted major competition coming from open source models and also significantly from China.
Yeah, the open source momentum is really clear. Models like Meta's Llama, they're closing the performance gap fast compared to the proprietary ones.
Yeah.
But their big advantage is they're fully downloadable, customizable, often at a tiny fraction of the cost.
And people are using them.
Massively. The data showed Llama downloads topped 1.16 million by April 2025. And that led to over 100,000 derivative models being built on top of Llama. Developers are clearly flocking to these cheaper, flexible options.
Okay, then there's the global picture. The analysis described the US-China AI competition as like an AI space race.
Right, framing it not just as tech leadership, but a race to prove innovation, to win global trust. Similar vibes to the US-Soviet space race back in the day.
And China's focus.
The material points to China really accelerating its efforts in strategic areas like AI since about 2015, tied to plans like Made in China 2025.
Any specific examples mentioned?
Yeah, Alibaba's Quinn model was highlighted. Sources stated it surpassed GPT-4o and Claude 3.5 on some reasoning tests. And Alibaba released 100 open-source versions of Quinn. Baidu's Ernie model was also mentioned multimodal, and apparently significantly cheaper than competitors. The data also showed China having a larger installed base of industrial robots than the rest of the world combined.
And the material addressed potential risks too, right?
Yes, it impartially presented perspectives raised by some sources about potential risks if authoritarian regimes take the lead in AI, mentioning concerns around data sharing, surveillance, cyber weapons. It also noted the context of rising trade tensions and U.S. efforts to protect its intellectual property, just presenting the viewpoints found in the sources.
Okay, so while that global race plays out, The big established tech companies, they're not standing still. They're integrating AI deep into their existing products, leveraging those massive user bases they already have.
Microsoft is a prime example. They're embedding Copilot everywhere. Microsoft 365, GitHub. The material said cumulative Copilot chats hit 15 billion by the end of 2024.
And our business is planning to use it.
Seems like it. A survey of CIOs in late 2024 showed 76% expected to be using M365 Copilot within a year. And financially, the analysis estimated Microsoft's AI product annual revenue run rate hit $13 billion in 2024. That's up 175% year over year. Huge growth.
What about Meta?
Meta AI also saw massive user growth, nearly 1 billion monthly active users by April 2025. And the material included a quote from their CEO expecting Meta AI to be the leading assistant, reaching over 1 billion people. And he predicted their AI engineering agents could reach mid-level human coding abilities by 2025.
Wow. And Google.
Google's rolling out Gemini across its products too.
Yeah.
Chatbots, those AI overviews you see in search results now.
Right, but it's not just the absolute giants, is it? The sources gave some really eye-popping examples from other software companies using AI.
Oh yeah, absolutely. Adobe Firefly for image generation, over 16 billion images generated. Atlassian Intelligence hit over 1 million users. Zoom's AI companion saw user growth jump 68% quarter over quarter. Canva's Magic Studio, Salesforce's Agentforce, which got 3,000 paying customers in its first 90 days. Lots of integration happening.
And then there were those specialized software companies focusing on specific industries. The growth there seemed off the charts.
Totally. Look at software engineering tools. Aniosphere Cursor went from $1 million in annual recurring revenue, ARR, to $300 million. In 25 months.
300 million. Incredible.
Product development. A company called Lovable saw its ARR jump 13 times to $50 million in just 5 months.
5 months. And healthcare.
Huge impact there. A Bridge does AI summaries of patient visits, used by most Kaiser doctors. Their ARR went from $50 million to $117 million in 5 months, covering over 10 million patient summaries.
Okay, legal tech.
Arfi, an AI legal tool, grew from $10 million ARR to $70 million in 15 months. Serves most of the top U.S. law firms.
Customer service.
Yeah.
Financial services.
Customer service. Decagon went from $1 million to $10 million ARR in a year, 10x growth. Financial services, AlphaSense, AI market intelligence grew from roughly $150 million ARR to $420 million in 2 years.
So these examples really drive home the point. AI isn't just a big tech thing. It's enabling this kind of hyper-growth for specialized tools across all sorts of industries you might work in or interact with.
Absolutely. And remember that falling inference cost we talked about? The cheaper cost of using the AI? That's a huge enabler for all these specialized tools popping up and getting adopted so quickly.
Which leads us right into AI's impact on work itself and maybe where this technology is headed next.
Yeah, the material talks about AI bringing cognitive automation. So not just automating physical tasks like robots do, but automating tasks that need, reasoning, creativity, problem solving.
And the pace of improvement in this cognitive abilities is just mind-bending. The analysis suggested AI reasoning went from maybe a high school student level in 2022 to potentially a PhD level by March 2025.
Yeah, that's a pretty stunning claim about the acceleration in just 3 years.
And we're seeing real examples of this hitting the workforce already.
Definitely. The material referenced a memo from Duolingo's CEO. He basically declared the company AI first, saying AI is already fundamentally changing how they work.
And there was that specific example,
Yeah.
almost hard to believe.
The chess curriculum.
Right.
Built entirely by 2 people. Neither knew programming, neither knew chess. They did it just by using AI tools.
Just incredible. And Duolingo is apparently even tying AI use to things like hiring and performance reviews.
That's what the material indicated, yeah, making it really core to how they operate.
And across the economy, are firms adopting AI?
The data shows they are. U.S. firms reporting using AI to produce goods or services saw a 21% jump just quarter over quarter in early 2025. And studies mentioned showed real productivity gains. Like customer support agents using AI were 14% more productive.
And this is reflected in the job market, too.
Big time. Looking at job postings from 2018 to early 2025, AI job postings went up 448%. Meanwhile, non-AI IT job postings actually decreased by 9%. Clear shift in demand.
There was that quote in the material from NVIDIA's CEO, Jensen Huang.
Oh yeah, you're not going to lose your job to an AI, but to somebody who uses AI.
Which really frames AI not just as a replacement, but as a tool for empowerment, right? Suggesting that knowing how to use AI effectively might become a crucial skill, like knowing how to use a computer became essential.
Exactly that interpretation. And looking further ahead, the material listed these next AI use case frontiers, areas like medical discovery, precision manufacturing, robotics.
And there was a detailed example on protein sequencing.
Right, showed massive growth in the size of AI models tackling this.
Right.
And how tools like AlphaFold expanded the number of predicted protein structures by, like, 1,000 times compared to what we could figure out experimentally before, showing AI driving fundamental scientific breakthroughs.
So for you listening, the takeaway seems clear. AI is moving fast from abstract concept to a technology actively shaping jobs and industries. Getting comfortable with AI tools looks like it might become as essential as basic computer literacy was for past generations.
And finally, the material explored this really mind-bending idea about global access and the future of the internet itself. The concept of an agent-first internet.
Okay, tell us about that.
Well, first consider there's still 2.6 billion people not online yet. That's almost a third of the world.
Wow, still that many.
Yeah. And the analysis suggests that for many of them, their first experience online might not be using a web browser or search bar. It might be interacting directly with an AI agent, maybe speaking their own language, skipping the whole traditional setup.
So instead of learning to navigate websites, they just talk to an AI.
That's the agent-first idea. Instead of you opening specific apps for tasks, you'd interact with one AI agent. It understands your context, what you want to do, and then it manages the different tech platforms behind the scenes for you.
And the potential impact.
The material suggested this could really upend existing tech hierarchies. The winners might be whoever controls that main AI interface, not necessarily the owners of the individual apps it connects to. A potential major shift.
And what makes this future more plausible now?
Well, obviously, the AI agent tech is advancing rapidly, but also global internet access is expanding in new ways. Satellite internet, like SpaceX's Starlink, is bringing connectivity to places that were totally offline before.
Right, the data showed Starlink growing incredibly fast.
Yeah, subscriber growth was accelerating, like 202% annually over a few years, reaching over 5 million subscribers. It provides that crucial connection for remote ships, isolated communities, places that could be prime candidates for this kind of agent-first online experience.
So imagine, your first experience of the digital world isn't typing into Google, it's having a conversation with an AI that gets things done for you. It sounds like science fiction, but the pieces, the AI, the connectivity they're falling into place right now, suggests a really different future for how people might interact online.
A profoundly different potential future, yeah.
Okay, phew, that was a really deep dive into a huge amount of material. We've covered, let's see, the incredible speed and scale of AI adoption and investment.
Right, the compounding tech improvements driving performance, sometimes beyond human levels.
The shift towards AI agents that can actually do work.
The massive infrastructure build-out, data centers, chips, the energy demand.
The really complex economics, the fierce competition, that global space race dynamic, especially with China.
And AI's impact, right now, on work, on specific industries seeing hypergrowth.
Exactly. The picture painted by the analysis we reviewed is pretty clear. AI is fast becoming foundational, like electricity was, or the internet. It's not just another app. It's likely to be woven into almost everything in the coming years.
That seems to be the central message.
And the material also kind of hinted at this duality, didn't it? This tension between a race to the bottom, maybe cutting corners on safety or ethics, versus a race to the top, driving incredible innovation and benefits.
It did touch on that potential divergence. So maybe a final thought, based on everything we've just unpacked from the material. Here's something for you, the listener, to think about. Which of those futures seems more likely right now? Will all this intense competition and blindingly fast innovation mostly lead to good outcomes for everyone? Or do the very real challenges we discussed, the energy demands, the geopolitical tensions, the disruption to jobs, pose huge risks we need to manage carefully? Which path does it feel like we're on? And maybe what would it take to steer things towards that more optimistic outcome? Something to mull over.
That's it for this deep dive. Thanks for exploring with us. If you learned something new or sparked an idea, don't forget to like, comment, and subscribe. Got a topic you want Nova and Echo to break down next? Drop it in the comments. Until next time, keep prompting, keep building, and keep doing it with AI.